So essentially, yesterday's lesson, by the end of it, what you were supposed to be able to do, or at least one of the things you were supposed to be able to do, was tell me what my x-intercepts would be without graphing it. So from the factored form, it's really easy to tell what the x-intercepts are. So here's an example. Yes. So I don't know if you got this far, but think about what it would be if you had to guess. The x-intercepts are 3 and -5. So knowing that these x-intercepts are 3 and -5, you can kind of see where they are in the equation. But my x-intercepts are a +3 and a -5. So apply that pattern to this next one. Don't say it out loud, just think about it. Based on the pattern. You should all be looking at the screen, it's only on the screen. Or John, whoever's voice I hear. All right, so these x-intercepts are -4 and -7. So do you see like how the number is there, but then the x-intercepts are like the opposite of that number? You see that? So now think in your head what this one will be. All right, what are my x-intercepts for this one? Good try. +1 and +2. So it's like these numbers, but then the opposite, like opposite sign. Okay, here's another one. Oh, okay, so in yesterday's lesson, they either looked like this, or they looked like maybe just a single term outside times a binomial. We haven't gotten to where we have a number in front of the x then, because then that would change what the 0 is. You just have to be able to identify when it looked like this. It is 5/2 and -6. So we're not here to that part yet. Notes yesterday. So here's a graph. In this activity, you're supposed to identify x and y intercepts. I hope you guys know how to do that. Where does it touch on the x-axis? Where does it touch on the y-axis? And they gave you both forms of the equation. So we have our standard form and our factored form. And then you're supposed to notice some patterns. So you're noticing the pattern, kind of like in those flashcards I just showed you, that the x-intercepts tend to be these numbers, but like opposite symbols. And then going through this activity, what you were supposed to notice was that the y-intercepts are better seen from the standard form. It's always that like constant, the single number, the one that's not attached to any variables. So from this one, we identified our x and y intercepts, and we saw like where it was found in the equation. Questions on that? And then when it happened to be in the factored form, a single term times something we've kind of already seen, one of the x-intercepts ended up being 0. And then same thing with graph J. Here's a single term times a 2 term. When that happens, one of your x-intercepts is 0. Okay, but that's what was yesterday's activity. We'll kind of touch on that again in today's, but now that I've recapped that, hopefully that makes this warm up a little bit easier. So you have this graph labeled with A, B, C, D, E, and F. You're gonna identify all of those parts, preferably without using graphing technology. They're giving you the factored form right here. So from that, be able to identify the values for A, B, C, D, E, and F. I'll give you 2 to 3 minutes to do that. So, John or Uli, what is the value of AB based on the given information. Can you tell me what part of the graph AB is? Well, it is on the negative side. What do we call it when it touches the x-axis? And then class, what's another word for x-intercepts that we learned this unit? Zeros. Okay, good. So, we just kind of talked about it. If we have the factor form, we should be able to identify our zeros. So Uli or John, can you tell me what this one is, AB? You should be able to tell me what exactly it is based off of this format. So we'll come back to you, but that's the one you guys have to figure out is AB. Table 7, can you tell me what CD is? So the other x-intercept, can you tell me the coordinate of it? Can you tell me what the zeros are from the equation? Okay, not 1.6, but close. Class, can we adjust that? No. Ron, okay, negative 1.6, and since that's an x-intercept, that's gonna go in the x position, right? X-intercept is when y is 0. And then class, what's the other x-intercept, the other 0? Based on this part of it. A positive 2. Because it's, yeah, it's opposite. Fine. Question? Maybe after Adriana. So then now we kind of got that part. So table 6, can you tell me what AB is now? No. If it's on this side of the graph, like you told me it was the negative side and we identified our zeros from the equation, which one does it have to be? Negative.
Oh, negative. Oh, shoot. Well, I forgot.
Okay. Table 7, what's CD? Okay, good. Questions on that? I know you didn't have me for lesson 10. So I'll cut you guys a little bit of slack. But like, are we understanding now why it's that? Okay. Now, I mentioned this just a couple minutes ago. About how to find EF. Table 8, can you tell me what part of the graph EF is? What is it touching? It's touching the y-axis, so this is my y-intercept. In lesson 10, what form is it better to see the y-intercept from? There's lesson 10 again, in case you guys forgot, I'm asking all of you. Can I see the y-intercept better from standard form or factor form? Asking everyone, anyone can answer. You can see the y-intercept better from standard form. Okay, so like if my y-intercept's 3, it's that single 3. That's a standard form equation. I can't really see it from my factor form. If my y-intercept's a positive 4, I can see it really clearly in my standard form equation. If my y-intercept's negative 9, I can see it really clearly when it's in standard form. Are you with me so far? So when I have the equation, which is in factor form, I should consider transferring it to standard form so that I can identify the y-intercepts easily. How can I make this standard form? Good, so that's what we're gonna do. But that would be a little better for finding my y-intercept. So I'm gonna take the term from the first parentheses, multiply it by both terms in the second. Table 9 was x times x. X squared, table 1 was x times -2. -2x. And then we still have to distribute that 1.6, so we're double distributing, remember? Table 2 was 1.6 times x. And table 3 was 1.6 times -2. Okay, great. And then you combine like terms in the middle. Class, what's -2x plus 1.6x? -0.4x. So now that it's in standard form, table 4, can you tell me what my y-intercept is now that it's in standard form? -3.2. And if I'm writing it as a coordinate for my y-intercepts, the x is 0. And then from my standard form, I can see my y-intercept better. And that'll go through that. Good, questions, comments, concerns? Now you might be wondering, couldn't I just type that equation in Desmos and find all those parts? Yes, you could, but I'm telling you right now, on your test, you're gonna have a problem that looks just like this. Except for that, it'll have values for the A, B, C, D, E, and F. And it'll ask you to make the equation. So you won't have something to type in Desmos and click on. You will have to know from what we're talking about what the equation could look like if they give you the x-intercepts and the y-intercepts. Okay, questions on that? All right, also real quick, is this y-intercept also my vertex? What's my vertex? Like, I mean, not the value of it, but how do I know what my vertex is? The lowest or highest point on the graph, which clearly looks more this way. Today, we're gonna learn how to find the vertex from the zeros and stuff like that. Questions? I'm gonna briefly read you the goal of today. So we're graphing some quadratic functions in factor form. By the end of it, you should be able to graph them and know how to find the value of the vertex and x-intercepts when it's given in factor form without graphing it in Desmos. Because remember, you don't get Desmos on your state testing. So unless you want to go check out a graphing calculator from the bookstore, highly recommend. You don't have to pay for it as long as you don't use it. Then you can have a graphing calculator for your state testing, but you don't get Desmos on the treatment. I'm recording right now, just like I do every day, so it's always there. If you need to work backwards or ahead. We're almost to the end of the unit, so yeah, you need to catch up if you're behind. Hopefully, the people that have been gone a really long time for whatever reason are keeping up. Because we are testing not next week, but the week after. That means binder check is next Friday, 7 days from now. Puzzle piece is lesson 11. Friendly reminder about this, if you have not finished and resubmitted your coloring activity, you really want to do that because it's considered a project grading here. And you could get some extra credit if you do the coloring part, which involves you adding your answers and simplifying them to know what to color it. And I would highly recommend the extra credit on that because if you have over 100% in any category, it really helps your grade out. So highly recommend just upload it to Schoology when you finish it. but it's due no later than next Friday. We do have a small quiz today. It didn't have anyone have trouble finishing, so it'll be like the last 20 minutes to pass. Any questions? Okay. So back to the activities. And we're kind of picking and choosing because we have that quiz today. So we are gonna look at this part of your paper. We have the functions f, g, and h. You're gonna predict the x-intercepts. What's another word for x-intercepts? Zero is good. So we kind of already done that at least 3 times today. You're gonna predict the x-intercepts for each one. And then you're gonna predict the x-coordinate of the vertex. So I expect you to be able to get this column right. This one is just more of a prediction. It's okay if this column's wrong, but I do expect this one to be right. I'll give you about 3 minutes to do that. So, and I want to hear from people that haven't spoke yet today. So table 4, what are my x-intercepts for f of x? Okay, good, that's right. So when it looks like this, it happens to be these numbers just with opposite signs. You'll see why it's that in a later lesson. But for right now, we're just doing it off of what we've observed so far. Now, this next part's a prediction. I kind of expect you to have it within a certain range of numbers. But we'll see. Table 5, what would you predict based on these x-intercepts? What the x value of the vertex would be? So you should only have one vertex, right? Like that's your turning point of the U. So let me jot down some notes really quick. Vertex is the turning point of the graph. So it should really just be one coordinate. And right now we're just asking to estimate the x value of it from our x-intercepts. So if we want to stick with, you said -1 first. As a prediction, I'm not saying that's right yet. I'll show you why it's right or wrong in a little. We can know that that's reasonable, since if these are my x-intercepts, here's how they would probably look on a graph. So I'd have an x-intercept at the -3 and +5. What we know about our U-shaped graphs is that the vertex is always between my x-intercepts. So it can't be like -4, that would be outside of the range. But, and I don't want to give away the answer yet, but it's gonna be somewhere between -3 and 5. Question or answer, Jack? What do you think the answer is? Okay. I will say which one is right later. I will prove to you, but right now this column is just predictions based on this knowledge. That the vertex would have to be somewhere in between. So then table 6, what are my x-intercepts of G of x? Other 3 is one of them. So for this one, we have a single term times a 2 term. Let me go back to my lesson 10 notes where we saw some of that. So like function I, if you look at function I here, we have a single term times a two term. Those x-intercepts were 0 and 5. Over here, when we had another single term times a two term, those x-intercepts were also 0 and 5. So table 6, what's gonna be my other x-intercept for this one? Good. When it's a single term times a two term, that single term, the x probably has to be 0. So there's that. Now, table 7, we're on to that. Estimate, please, the x coordinate of the vertex if these are our x-intercepts. Okay, you're saying 3. You're saying the vertex is right underneath one of the zeros. The prediction, we'll see in a little bit. Table 8, what about the x-intercepts for h of x? Give me 1 second. -4, I would agree with, and then what's the other x-intercept? So it won't be 0. I know this is like a reverse order, but class, what should the other x-intercept be? 4. Okay, because they put the x second, so you could think about it as 4 minus x, -x plus 4. I don't know how to say it right now without telling you the answer. So just know that that one should be 4. And that does kind of follow a pattern from yesterday. All right, now based off of those x-intercepts, table 9, can you estimate what our x coordinate of the vertex will be? Okay, things going to be -4. All right, so again, I'm not saying that these are right or wrong yet in this column. The middle column is right, so I expect you guys to get that right. So now let's prove it to you, and you can jot down some key observations. So if I graph the first one, f of x, all right, so you did get the zeros right. -3 and +5 are my zeros. The x value of my vertex was 1. So it happens to be right in the middle of my zeros. So change that prediction to what it actually should be now. The x value of my vertex is 1. Here's how to do it without looking at Desmos for that answer. You have to think about what the middle point between -3 and 5 would be. That middle way would be 1. If I go 4 from -3, I end up at 1. So 1, 2, 3, 4. If I go 4 from the 5 to the left, 1, 2, 3, 4, I end up at 1. That's why that is my x value of the vertex. The vertex will be in the middle of your 0. If you, because at some point they do get really far away and it's hard to find the middle point, think of it as averaging these values. So like -3 plus 5, and then averaging is where you add them up and divide by however many numbers you added. What's -3 plus 5? 2 divided by 2 is 1. So that's how you can estimate it. Well, not estimate it, but the actual answer. So then apply that same logic to the next two. What's the middle point between 3 and 0? 1.5, and that's what your x value of your vertex is for that one. You do 3 plus 0, which is 3, divided by 2, 1.5 is my x value of my vertex. And you could put it in the calculator if you want to see it. Proven to you. What's my middle x value between -4 and 4?
0.
0. But if you add them together, you get 0, and then divide by 2, you get 0. Or just think about it. That really is the middle point between -4 and 4. Questions on that? All right, now the y value of the vertex, we also need to be able to find. You are going to find the y value by plugging in the x value. So make a note to yourself somewhere about that. To find the y value of vertex, plug in the x value of vertex. So if you have to identify the vertex from your factor form, that's what you'll do. You'll use your x-intercepts to estimate the x, plug it in, and then solve for y. So if I do that for this one, if my x was 1, or I know you might not have a whole lot of room, this, I mean, there's a backside too, if you need to, but just fit it in somewhere. That f of x could be replaced with y. What's 1 plus 3? 4, what's 1 minus 5? Positive or negative? And then multiply them together, what do we get? -16. So I know it only asks about the x value, but you need to be able to, from the vertex, give me the equation. So that's how you find the vertex from factor form. Ron, is it about this? Is it about this? We're gonna do that. All right, now do the same with the others. We correctly identified the proper x value. Plug them in and be able to find the y value of the vertex, again, without graphing. You can use a calculator to do the math, but you're not using it to graph this time. So I'll give you 2 minutes to do that. That's actually way too long. I'll give you 1 minute to do that. Find the y value now of our vertex. Table 4 is on. So g of x is shown here. You had the x-intercepts. We estimated the x value of our vertex to be 1.5, because it should be in the middle of your x-intercepts. To find your y-intercept, or not your y-intercept, your y value of your vertex, you plug in that 1.5 for the x. Simplify and solve. What's 2 times 1.5? And 1.5 minus 3. Multiply these two together, you get -4.5 for your vertex. All right, when I type in the next one, 4 minus x. All right, you see that our x-intercepts are the same that we predicted them to be from the factor form. My vertex for the x is 0. I get my y value by plugging in the 0 and solving for the y. Because remember, this is equal to my output, the y. So then I have 0 plus 4, 4 minus 0. What's 0 plus 4? Come on, fast, or else we won't have as much time to quiz as my other classes. 0 plus 4 is the question. 4 minus 0 is 4 times 4 is, and look, that's my y value of my vertex. Imagine that. All right, I also have to tell you how to find the y value of from standard form. So I'm gonna have you write down these steps. So on the back side, you have like a whole blank sheet. You are writing down how to find the vertex from standard form. And remember, standard form is the one that looks like ax squared plus bx plus c. How to find vertex from standard form. Because that's important too. So step 1 would be to identify the x value of the vertex through the axis of symmetry formula. Here's that formula. You'll be asked about that on your test. Not today, but like your unit test. So if you have it in standard form, you can use this formula to estimate the x value of your vertex. Remember, standard form uses the letters A, B, and C, which represent numbers. And we have B and A in our formula. That's where we're getting these values from. So I made this random example. You've probably drawn in the example as well. So 4x squared minus 2x plus 1. When I plug it into my axis of symmetry formula, what's my B value? -2, so that's why I plugged in a -2. And what's my A value? The 4. So, yeah, this is A, because it's front of the x squared. This is B, because it's in front of the x. This is C, and we don't need C for the axis of symmetry. So then in the formula, it was -B. That's why I put a -2. What happens to that double negative? So that's why it became a +2. On the bottom, 2 times A, 2 times 4 is 8. And that simplifies to 0.25. That's going to be the x value of my vertex. Here's the rest of the steps. Once you have the x value of your vertex, just like we did for the last situation, you plug in the x value and solve for y. So this was my original equation. Notice in the S, I plugged in what we estimated x to be. I use my calculator to tell me that this equals 0.75. So here's my vertex as an ordered pair. 0.25 for the x, 0.75 for the y. Questions, comments, concerns? The quiz that you are doing today is very short. It's like 4 questions, so I have faith in you. I will still be able to finish. The password, I'm not gonna put it on the internet.